Good morning, Paula. How's it going? So a couple questions you had. Question number 3 um, gives you a set of data, and it says if you took the following data and constructed frequency histogram with a first class of 0 through 9, a class width of 10, how many values would be in the second class? So it's important things to know about a histogram. Um, all of your data parts have to be the same. So if this is 0 to 9, and the one next that has to be 10 to 19 and 20 to 29. In this problem, it says that they're 10 long each. So you know that, I know it's counterintuitive, it seems like 9 numbers, but it is 10 numbers. Okay, so those are your 10 numbers right there, zeros included as the number. So pretty much what they're asking is, they said in the second set, in this set right here, how many numbers are there? So essentially they're asking you how many of these numbers fall between 10 and 19. No, 1, 2, no, not 20. Nope, 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 3. So, how many values would be in the second class? 3. Okay? Good. So again, your second class is that second group of numbers that we just talked about, and that will be the numbers between 10 and 19. So a fancy way of asking you which of these numbers fall between 10 and 19. Okay, but the big thing is you want a number is that it's always got to be the same size for each one of your categories. Question number 4. That's not your picture. Where did I get your picture? Looks good though, huh? Alright. This is question 4. No, that's the same one. Question 4. Okay. If you took the following data and constructed a frequency histogram, the first class is 0 through 9, and the class width of 10, what would be the relative frequency of the second class? Well, we went back and we said that there were these numbers between that fit in that second class. So these were the numbers that fit in the second class, right? There were 3 of them, okay? And you have 20 altogether. So that's 3 out of 20. That's your relative frequency. And 3 out of 20 is going to be, I don't know, 0.15. Okay, so your relative frequency is 0.15, meaning that these represent about 15% of your numbers, okay? So again, if you wanted to know, you can break out your calculator and just say 3 divided by 20. Your calculator is not going to turn on, I guess. So yeah, 3 divided by 20. Okay, and you should get 0.15. Okay. So yeah, that's it. All right, and I believe you said 7 and 9. Switch 7 and 8 now. All right, so these came out. Was it 6 and 7? Yes, it was 6 and 7. Sorry, I go check my emails, see which ones you wanted to know about. So yeah, so 6 and 7. So yeah, it gives you the what's the sample correlation coefficient. I'm assuming from your picture, from this picture, that you're allowed to use a calculator. So yeah, so pretty much what a correlation coefficient is just pretty much how much it comes to being a specific type of answer. So they gave you these answers. I think I might have to do the other picture for this table. So yeah, to find your correlation coefficient, you're going to use a calculator, I hope. If not, then I might have to do a little bit of homework. But yeah, it's a little, it's not too bad. The first thing I encourage you to do whenever you're doing these types of problems is you need to turn your diagnostic on your calculator. I don't know why it's not on, but if you look down here above 0, it says catalog in blue. The easiest way to do your diagnostics is press second catalog. Okay, it's going to bring up everything your calculator does. If you notice in the top right-hand corner of your calculator, there's a little A, which means that you can go by alphabetical order. So if you notice, above most of the buttons on your calculator, there's little green letters. So math says A, app says B, program says C, and so on. So we want D for diagnostics, so we're going to press that one right there. And we're going to scroll down, and we're going to turn your diagnostic on. Again, I'm not sure. Oh, press enter, make sure it's done and it's on. Okay. Again, I'm not really sure whether you need that for this problem. I think you do. But regardless, now it was like one of the first things you should never turn that off. But if you reset your calculator or anything, you're going to have to do it again. So to enter the data, we're going to have to go to stat right here. Stat. I can't draw on right here. Stat. Okay. Stat, and then we're going to edit the first one. Okay. So variable 1, 5, 10. Sorry, you have to watch me punch in all these numbers. 20, 25, 30, 40, 30, 40, 50. I hope that's 60. Oh, that doesn't help. Alright. I think that's 50 and 60. If not, hey, put in the numbers that are right. 60 and 65. Okay, the worst thing you can do in this situation is not enter the same amount of numbers. So here in variable 1, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And do I have 10 numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9. No, I missed one. 5, 10, 20, 25, 30, 40. There's a 45, right? So again, I almost made the mistake I told you not to make sure every number is in there. 45, 50, 60, and 65. So again, this is L10 there. Again, that's kind of gave me a heads up that I knew that wasn't the right amount. Go over to the next column, make sure you write the right corresponding numbers. 31 correspond with 5, 30 correspond with 10, 27, 22, 18, so on and so forth, 15, 12, 10, 6, 3, okay, and again, we should be all good. So now that you got your data table, again, you want to go back to stat, so go back to stat. We want to calculate, so move over, calculate. And then I guess correlation coefficient. I think you want to do a linear regression. Sumo wants to be linear. It doesn't normally tells you whether it should be linear or not. Don't change any of these. Do not change any of these. Okay. So to give you this. So you have right here, A, B, that's the equation of your line. R2 is your standard deviation, and R value is your correlation coefficient, okay? So notice your correlation coefficient is negative 0.9938. That means that there is a very, very strong correlation between these two numbers. It essentially means if you graph these two sets of numbers, that pretty much you'd have, you know, your data will be coupled, something like that. So pretty much you can almost draw a line straight through it, okay? And I know this line is going down because your correlation coefficient is negative 0.9938. So the negative is just as good. So your ranges for your correlation coefficient should be between -1 and +1, okay? So 0 correlation coefficient sucks. It's not close to either one of them. If you have a correlation coefficient close to 1, it's a strong positive correlation, meaning as one goes up, the other goes up. Here you have a strong negative correlation, which is going down, which makes sense because these numbers are generally going up, and these numbers are generally going down. So that's reflective of our information. Again, double check what your professor wants. I assume they want a linear correlation. It doesn't say anything otherwise. And then, yeah, the set of data. What's the critical value for the correlation test? Again, I can't really see these numbers. I'm assuming 0.997. It's Yeah, so 0.993 is 0.994, I guess. So it looks like whatever this number is in here, I think. Again, I can't really see, it didn't come out on the other picture. I don't think so anyway. So, yes, well, it looks like 0.997, which is the closest one you got here. So again, so your end value should be, it looks like 3, I guess. I don't really know. So, but whatever, this is the number right here, so take that and compare it to what you got. So, anyway, Paul, I hope that helps. If you got any questions, stop by when you get here, and I'll talk to you soon. Take it easy.